Hello everybody and welcome to this day 3 of the ROS2 learning week. Hello everybody. Today we are going to start with ROS2. So for that it would be great if you have completed the Linux and Python 3 courses so that you get all the fundamental knowledge that you need in order to start learning ROS2 on top of that. All right. So I don't know. Let me know here in the chat if you have been able to finish the Python 3 course. I know that many of you did complete the Linux course, but I don't know about the Python 3. So have you been able to complete it? Where did you get to in the course? Let me know in the chat. Okay, Boris finished it just a few hours ago. Ricardo finished it also. Also Samuel. Almost done for WalkTech. Yamin says also that yes. Okay. Okay, great. Then so we are ready to start with ROS2. So again, today we are going to start with the very basics. So don't worry if you don't have any previous knowledge about ROS2, okay? Because we are going to start from the very basics. So let me not lose any more time. I'm going to switch already to my computer screen here. Let's go there so that I can go to the ROS2 Learning Week main page. And I can check here the chat and everything. Okay. Yeah, I can see Ricardo is asking you to put profile pictures to your account. Yeah, that would be nice because then we can have some pictures here instead of just the letters, like for Samuel or WalkTech. Let's see this. I don't see what exactly is that image. Interesting. Is that a bird or a mosquito? I don't know. I like this one. Yeah, Seba has a really cool picture there with Darth Vader. Good job. Good job. All right. Okay, so today we are going to change just a little bit the way of doing the class. Okay, so for days 1 and 2. Remember that we were basically following a course here in the academy, right? So today we are not going to follow a course, but we are going to work with a ROSject. So a ROSject is what we call, is a name that we have provided to a kind of ROS project, which is packaged, and that you have everything in a single click, yeah? Then you might be asking, okay, so how do I get the ROSject for today's class? It's very easy. Write down here the live stream where we have the description. You are going to see open this talks ROSject. You are going to see this button here in light blue. So all you have to do is click here. Okay? By clicking here, you are going to automatically get a copy of today's ROSject, and it's going to also automatically redirect you to the ROSject page. So I'm going to click here myself so that you can see what happens. See? So let me mute me here. So as soon as you click on the button, two things happen. First, you get a copy of the ROSject. And this copy, you're going to have it forever in your account, okay? Not only for today, but if you want to access this ROSject next week, next month, you are going to have it in your account, okay? Very important thing to know. And second, as you can see, you are going to be taken here to the ROSject main page, all right? Then there is nothing very strange or different from what we have been doing. So as you can see, one of the things that are going to be automatically opened when you come here to the ROSject is a Jupyter notebook. Okay, so we are going to work with a notebook also, where there are all the instructions that we are going to be following, all the theory, exercises, codes, etc. Everything is here inside the ROSject. Okay, the difference here is that this environment is more meant for developing. Okay, so you can move everything, you can maximize, minimize, so you can organize all the space as you want. Also, I'm going to be explaining you how to open the shells and how to open everything, okay? And also, additionally, you can see here at the right side, you have the streaming panel, okay? So in the streaming panel, you are going to have the live stream for sure, and you have the chat as well here in order to write questions, feedback, whatever, yeah? And again, if you still prefer to have this in a different tab, you can just click here, okay, and then it's going to move all these to a different tab. I'm going to leave it here for now, because this way I have a quicker access to the chat. Can you repeat that very important thing? It got cut when the project opened. I don't know, because I say many important things. So I don't know which specific one is this one that you are referring to, Sergi? I get an error message. Okay, maybe Sergi, maybe it is that that this copy of the project that you get in your account, you are going to have it forever. Okay, not only for today, but you are going to have it in your account forever, so you are going to be able to access it next week, next month, even next year, okay, in order to review things, whatever you want to do. Maybe it was that. Okay. Yeah, so let me show it again, just in case that somebody missed the steps. Yeah, so here in the main ROS2 Learning Week page, all right, right below the live stream video here, yeah, in the description box, you have this button here, Open this Talks project. Yeah, so everybody has to click here in order to get a copy of this project. Okay. Yeah, so let me know how it's going. Did the project load for all of you? Yes, no, still loading. Let me close all this. Yeah, so once it finishes loading, you should get something like this, okay, with the notebook automatically opened and the streaming panel here at the right side. Okay, got it, yes, loaded. After the class, how will we access this project? Is asking Joe Miller. Very easily in the construct page, okay. When you log into the construct page, you have a section here at the right menu which says My Projects. Okay. Then if you click here, you are going to have the project here. Okay. Project is the presentation. Yes and no. So the project is a full contained ROS project. Okay. Here we are going to explore all these during today's class. Yeah, but here there are packages in order to start simulations. There is you have an environment where everything is installed. Okay, so if you click here in the name at the bottom left corner, so you are going to see that this is an Ubuntu system actually which has ROS2 Humble installed in it. Yeah, so this is you can think of a project like a computer which is being loaded in the cloud and where you can work in your ROS projects, okay? And additionally, for this project that I have shared with you, I have added a notebook here with instructions so that you can use them to learn, to follow the exercises, etc. Yeah? Works fine. Yamine say, is saying no sound, but I think that sound is working fine. So maybe you just muted me. Yeah, Logan is saying, for some reason, for me, it defaults to mute. Okay, yeah, so make sure that this is not mute, okay? Matef is saying, I think it's more interesting to learn more about your amazing web learning interfaces than ROS2 right now. Yeah. Yeah, that's true. So if, yeah, if you, let me write it down here. If you don't hear me, verify that the live stream is not muted. All right, then I think that we are ready to get started, right? So, so yeah, as you can see here in Alberto, can you show how to mute? Yeah, so just you go to the stream, just like you would do with any video. Okay, you go to the video and then you have here the mute and unmute. Okay. In my case, I have it muted, okay? Because otherwise I would hear myself all the time. So I want to have it muted, okay? But this is muted, this is unmuted, okay? All right, then I think that it's enough for the introduction, so let's get started. Then, yeah, so we are going to start with the very basics of ROS2. So the very basics of ROS2. Hello. Okay, my chat got like gray for a moment, and I was worried. Yeah, I think there was like a micro disconnection, maybe. Okay, so I see that there is some people still a little bit confused. So I'm going to explain it one last time, and then we start, okay? So for the ones who are late to the class, okay, I have explained this at the beginning, but let me explain it one more time, okay? So in the ROS2 Learning Week, right below the video feed, here in the description box, you have the button to open this talk's project, okay? So everybody has to click on this button in order to get a copy of this presentation, if you want to call it, of this project, into your account. Okay, so everybody has to click here. Yeah? Then once you click here, you are going to get a copy of the project and you are going to be redirected to the page where I am currently at. Okay? And also make sure that you don't have the sound muted here in the video stream, okay? All right, and then if there are, I don't know if some people is having some errors opening. When I ask it, I could see that most of you could open it properly, the project, okay? So I assume that most of you have the project already loaded, right? Yes? Can you confirm here in the chat that you have the project properly loaded? Yes. Okay, great. Excellent. Then let's get started, all right? So, yeah, let me just do a quick introduction because ROS2, as you might already imagine, is a huge topic, yeah? So there are many things that you can learn. And me, myself, I have been working with ROS2 already for many years, but I'm just probably scratching the surface, yeah? So I could be learning my whole life about ROS2, and still I wouldn't know everything about ROS2, okay? Then we have limited time, so we are going to try to do as much as possible. Then what we are going to be learning today is the basic concepts of ROS2. What is ROS2? Okay, why is it so powerful? How you can get started with ROS2, creating a package, etc. Okay, and get familiar with some very basic ROS2 concepts like nodes, etc. Okay. Then all this, in case that you are interested, you have a link here to the complete course of ROS2 Basics. Okay? Well, don't click here. For me, at least, it didn't work. The link. I'm going to click it now, but open it in a new tab. There we go. Okay. Yeah. So I left here, just in case that you are interested, a link to the full course of ROS2 Basics, okay, where we are covering many more things like topics, services, executors and callback groups, actions, etc. Okay, what we are going to be doing today is ROS2 Basics, and tomorrow we are going to be covering ROS2 topics. Okay, but still there are many more ideas that we are not going to be able to do during the ROS2 Learning Week. But all this you can find it in the ROS2 Basics in 5 days course. All right, in case that you are interested. Okay, then let's get started. So the very first thing that we are going to do is to launch a simulation. Okay, as you already know, we don't like to teach by just talking or showing slides, showing videos. No, we like to teach by doing practice. Yeah. Then everything that we are going to be learning today, we are going to be applying it to a simulated robot. All right. So the very first thing that we need to do is to start our robot simulation. Then for this, we need to execute these commands in a shell. Okay. Now, in the course, you had the shells already opened for you. Here, in case that you want to open a shell, you need to open it specifically. Yeah. So how to do this? Well, here in the bottom right side, you have a menu with many options. Okay. The first one is the web shell. Yeah. So if you click here, this is going to open a shell for you. Okay. You can organize it as you want, make it bigger, smaller, however you want. Okay? Yeah, and this is a regular Linux shell, like the ones that you have been using for the courses. Okay? Then, what we are going to do is to copy these commands and paste them directly to the shell. Okay? Like I have just done here, and then hit enter, and we are going to execute some commands to start a gazebo simulation. Okay? Because here, in a project, the simulation is not automatically started, okay, like in the courses. In the courses, you access the course and the simulation is already there, loaded for you, okay? In a project, you have to start the simulation, yeah? Okay, and then if everything goes okay, you are going to have a gazebo window automatically opened, like this, yeah? You can zoom in to gazebo, and you are going to find here that you have a Turtlebot 3 robot. Yeah, this is a Turtlebot 3 robot. Let me put it here in perspective, with some walls here at one side, and the Turtlebot 3 robot here in the middle. Okay? This is the gazebo simulation that you should get after executing these commands. All right? So let me leave you some seconds so that everybody is able to start their simulations. Okay, let me know if you have been able to load the simulation. Like me, yes, no. Yes, 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 yes. No, no. Okay, the people who says no, it's because it is being loaded. It takes a hot minute, but yes, okay. Yeah, it might take some seconds, even up to a minute to fully load. Okay, perfect. Then let's go back to the notebook. Okay, so now that we have the simulation running, let's get started with the theory. So what is ROS2? Well, I could try to explain you now with words what is ROS2, but I think that the better approach is to start practicing and experiencing what ROS2 is and what ROS2 can do. Okay, so the approach that we are going to take today is to do some practice and follow some examples and exercises, and at the end, once we have been working a little bit with ROS2, we are going to be able to get a better idea of what ROS2 is and how ROS2 can help you in your robotics career. Okay? Then, we are going to start by moving a robot with ROS2. Okay? So how can you move a robot with ROS2? Well, the best and probably easiest way to move a robot with ROS2 is to execute a program that allows you to move the robot in some way, okay? So this is what we are going to do in example 1.1. We have a program which we already provide to you, so you don't have to do it because you still don't have the knowledge to create this program. So this program is already created and provided to you, and what we are going to do is to just execute it and move a little bit the robot using this program, okay? Then let's go back to the shell. So here, in this shell, we have the simulation running, okay? So we don't want to stop this, because if we stop this, if we close this terminal, the simulation is going to stop, okay? Then, in order to keep working, what we are going to do is to open another shell, okay? So, in order to do this, we can click on this Add button that you have here, and this is going to open another blank shell, so that we can start using it, okay? If you want, you can even rename the shells. For instance, if you double-click here in the first one, well, one click only, okay, you can rename it and say, okay, here I have the simulation, so that you know what you have in each one, okay? All right, then in this shell, we are going to execute these commands. So first of all, we are going to source ROS. In this case, we are going to source the humble distribution. Wait, I got a message. How would we open those in a local Linux system? So in a local Linux system, you would go to the menu. I cannot show it to you here because I am on a Windows system, unfortunately. But yeah, basically you would go to the menu and find the yeah, or there is a shortcut which is Ctrl-Alt-T, for instance. How to open a terminal? So to open a terminal here in the ROSject is just by clicking in this button here. Yeah, in the bottom right area of the ROSject, you have all the buttons to open different things. Yeah, the first one is the web shell, the shell button to open a terminal. Okay? Yeah? Are we good to go? Okay. All right. Then important, we leave the first shell terminal that we have here running, because here is where we are executing our simulation. Then we open a second one. Remember, to open a second one, you click on this Add button that you have here, okay? And you can open as many as you want here, okay? Then, in this new shell, we source ROS. In this case, we are sourcing Humble, the Humble distribution. Then we are going to source a ROS2 workspace. We are sourcing this workspace because inside this workspace is where we have the program that we are going to execute in order to move the robot. Okay? Yeah, we will explain in a moment the concept of workspace. Okay? And then, finally, we execute this third command here in order to start the program. Yeah? The command that we are executing here, this is a ROS2 command, and it's ROS2 run Turtlebot3 teleop keyboard, okay? I will explain about this command in a moment. For now, let's just execute it, okay? There we go. Then this program, what it does is that it allows you to send velocities to the robot by using the keyboard keys, okay? Let me put this. Actually, I think I might minimize this. Yeah, and because I have the chat also here, so that I have some more space here, okay? Otherwise, the space is limited here, so I'm going to do it like this, so that I can have more space to use here. There we go, okay? So this program, as you can see, it allows you to control the Turtlebot3 robot, which means that you can send velocities to the robot by using the following keys. A, W, S, D, the typical gaming keys that you use to move your characters in computer games, okay? So you can use these keys in order to move the robot and send velocities to the robot. Yeah? So, for instance, if I press the W key, the robot is going to move forward. You will see now. See how the robot starts moving forward? Okay? If I press the A key, the robot is going to start rotating to the left. See? If I press the D key, the robot is going to start rotating to the right. Okay? For instance, I press the W key again, the robot is going to move forward. As well. Okay? If I press the S key, this one, the robot is going to stop completely. Okay? So you can test a little bit, you can play with the keys in order to get used to moving it. If you want, okay? If not, it's not necessary. This is just to play and interact a little bit with the robot. And here we are interacting with the robot directly using ROS2. Okay? So here we are executing a ROS2 program. Until now, we have been doing some other things with Python, Linux, yeah? But here we are using directly ROS2. Okay? All right. Then we can already stop the program, yeah? Then let's have a look here. So what have we done here? We have executed a command, a ROS2 command, that allows you to run a ROS2 program. Yeah? Then there are two main ways in which you can execute a ROS2 program. One is directly executing or running the executable file, and the other one is to use a launch file. Okay? These are the two main methods that you can use in order to start a ROS2 program. Okay? Then, with this method, we are directly executing the program, the executable file. Yeah? And how does this command work? Well, you specify the ROS2 keyword. You will see that the ROS2 keyword is used for all the ROS2 commands that we are going to be using. Then you specify the run keyword. And then you have to specify the package name, the name of the package that contains this program, and then the executable file name. Okay? What does this mean? That the program that we have just executed is saying, okay, I want to execute this executable named teleop keyboard, which is contained inside this package, Turtlebot3 teleop. Okay? Then the second way in which you start ROS2 programs is using launch files. Okay? Then the command to execute to start a launch file is as follows: ROS2, then the launch keyword, then we specify the package name also, and then we specify the launch file. Okay? And inside this launch file is where you are going to start the specific executable or executables that you want to run. Okay? Yeah? Then we have introduced many concepts here, like executable, package, launch file. Yeah? So if you are new to ROS2, you might be thinking, what is this guy talking about? I don't understand anything of what he's saying, right? Okay, don't worry. I am introducing terms right now, but step by step, we are going to be explaining all this, okay? Then let's start by the beginning. So what is a package? What is a ROS2 package? Okay? Then packages are like, you can think of a package as a folder, a directory, where you put your ROS2 programs. Yeah? So ROS2 uses these packages in order to organize its programs. Yeah? So you are going to start working on a project. Let's say your boss asks you to create a program to move a robot from point A to point B. So the very first thing that you are going to do is to create a package. And then inside this package, you are going to put all the files, programs, launch files, everything related to this project. Yeah? Then every package is going to have a very similar structure, okay? First of all, we can differentiate between two types of packages, okay? In ROS2, you are going to find basically two types of packages. CMake packages, okay? The CMake packages are the packages that are going to contain C++ programs, okay? And then you are going to find a second type of package, which are the Python packages. And Python packages are going to contain Python programs, Python executables, okay? Then for this course, we are going to focus on Python packages. Then for most Python packages that you are going to find out there, they are going to have this common structure and these common files and directories, yeah? You are going to find a package XML inside, yeah? And this package XML file basically contains meta information about this package. So what is the name of this package? What is the version? What are the dependencies of this package, etc. Okay? You are going to find the setup.py file, which is the file that contains information about how to build this package, how to compile this package. Okay? Then a setup.cfg file, which defines where the scripts are going to be installed in the ROS2 system. Okay? And then you're going to find a folder which has the same name of the package. Okay? And then inside this folder is where you are going to place all the Python scripts that you create, all the Python programs that you create. Okay? This might look a little bit ambiguous right now, but don't worry, because in a moment we are going to start practicing with packages, and then everything is going to be much more clear. Okay? Then from this, we can summarize this into 3 main points. So every ROS2 program that you want to execute is organized, is contained inside the package. Okay? For instance, this program that we executed, teleop keyboard, it is located inside the Turtlebot3 teleop package. Yeah? So every program that you execute in ROS2 is organized inside the package. Then every ROS2 program that you create, you have to place it inside a package. Okay? So Therefore, packages are the primary organization system for ROS2 programs. Okay? Yeah. So far, so good. Are you following? Questions? No questions at the moment. There is an interesting point that I was reading here from Zacharias, which says, it is interesting that what we do in the second terminal takes effect to the robot in gazebo opened by something in the first terminal. Yeah? So we have the simulation running in this first terminal, and the program that we run and that we were interacting was in this second terminal. So as Zacharias is saying, it is interesting that what we are doing here, it affects what we have running here. And this is happening because ROS2 works with something that is known as topics, okay? Topics is the most important thing in ROS2. And we are going to learn about topics in detail tomorrow, okay? In tomorrow's class. So try to don't miss tomorrow's class because it's going to be very, very important, okay? No questions. Arpat is asking, in the simulation folders, which are packages? Okay. I'm going to answer this one. Actually, not yet. I'm not going to answer it yet, but I'm going to answer it. Okay, so just stay tuned in the following minutes, Arpat. Okay, then, okay, so we have the idea of what a package is, then let's go for it. So let's create a ROS2 package, okay? Then, for that, we can use this shell here if you want, and then we can source again ROS to make sure that we can use ROS2 commands. And then we are going to go inside the ROS2 workspace, okay? So if we run an ls command, you are going to see here that there are different workspaces here, okay? Not all of these are ROS2 workspaces, okay? But the most typical and common ROS2 workspace that you are going to create is going to be named ROS2 workspace, okay? So this is the one that we are going to be working with the most. Today and also tomorrow and also Friday, okay? Then let's go inside this ROS2 workspace, okay? Then inside here you are going to see that there are several folders, yeah? These three, the build, install, and log folders, all these are automatically generated when you compile, when you build a workspace, okay? Then this third one, the SRC, is the folder where all the packages are going to be placed, okay? So if you want to create a package, a ROS2 package, you have to put it in the source folder of the workspace, okay? Yeah, very important, yeah? So you are not going to create the packages here, in ROS2 workspace. You are not going to create the packages here inside the install folders. No, this is wrong. Okay? So the packages have to be inside the SRC folder of the workspace. Okay? Yeah? Then once we are inside the SRC folder, we are going to execute the following command. I'm going to copy it here from the notebook. The command is ROS2 pkg, which stands for package, create, okay? So I'm going to create a package, ROS2 package create, then I specify the build type. In this case, I want to create a Python package. As I was saying before, yeah, you basically have two types, the Python and the CMake or C++ packages. In this case, the package that I want to create is a Python package, so I have to specify it here in the build type. This is going to be a Python package. Then this is the name that I'm going to give to my package. In this case, the name that I'm going to provide is my package, okay? And then finally here, I specify some dependencies. So this package that I'm going to create is going to depend on other ROS2 packages. In this case, it's going to depend on the RCLPy package, okay? Every Python package that you create is going to depend on the RCLPy package. Why? Because this package allows you to create Python programs based on ROS2. Yeah? This package contains all the libraries and everything necessary in order to write ROS2 programs in Python. Okay? So basically this is a mandatory dependency when you want to create ROS2 programs in Python. Okay? Then I'm going to execute this, and we are going to see that we're going to get some output here. So now if I hit ls, you are going to see that a new package has been created here. My package, okay? You can go inside this package, of course, and then here you are going to see some folders, files that have been automatically created. Yeah? And you can find, for instance, here the package XML, yeah, which we were explaining previously here in the section. You can find the setup.py also here, right? The setup.cfg, and the folder with the same name as the package, which we have it here as well. Yeah? So all this is automatically generated when you create a package in ROS2 following, of course, the ROS2 package create command. Okay? Yeah? Then, at this point, I want to introduce you to something, because I don't want you to be working all the time with the terminal, although I am sure that you already know how to, because you have done the Linux course. Yeah? But here in the project, of course, you have also the possibility to work using a graphical interface, a code editor. Okay? Then how can you open this code editor? Well, if you go to the menu, here you can move to the second icon, yeah? Right at the side of the web shell icon, yeah, you have the code editor icon. So if you click here, this is going to open a code editor. It's here. There we go, okay? And then here you have access to all the workspaces and everything that you have in this project, okay? For instance, if you go to the ROS2 workspace, inside the SRC, you are going to find that you have your package here, okay? And then now I'm going to answer the question that one of you made previously, okay? This is just for answering that question, but you don't need to get into all these details now. But this simulation workspace is another ROS2 workspace, yeah? You can have as many ROS2 workspaces as you want, yeah? Then can somebody tell me, if I want to find which packages are inside this workspace, where do I have to go? Where do I have to look into? Can somebody tell me? SRC, okay, very well. So inside, if I go inside the SRC, I am going to find here all the packages, yeah? For instance, this is a package, which is named services package. This is another package, which is named T3 action package. Here, in this case, this is not a package, yeah, but this is a folder which contains many packages inside. Okay? So this is actually a repository which contains packages inside. Okay? Also, for instance, Turtlebot3 Simulations also is a repository which contains some packages inside. Okay? Turtlebot3 Messages, this is another package. Okay? This Dynamic Cell SDK also, it's another package. Okay? So all the packages, you can find them here. Yeah? And all these packages are the ones that we are using in order to execute this simulation. Okay? But you don't have to worry about this right now, okay? Because all this is already provided to you. Yeah, so we are going to learn from the beginning, step by step. So we start with an empty workspace with nothing. Then we are going to create our first package and start building on top of that. All right? Okay. Then let me take well, actually, where I have my project, it's here. Okay, yeah. So let me take a very brief pause because I want to very quickly talk you about the Robotics Developer Masterclass. Okay, so in these last years we have been doing a masterclass, that we are calling Robotics Developer Masterclass. Okay. And this masterclass is a learning program that we have created lately in order to teach all the required skills in order to land a job in a robotics company, in any robotics company of the world. Yeah, so the purpose of this Robotics Developer Masterclass is to prepare you to be able to work, to start working and to start a job in any robotics company of the world. Okay? And it takes you from the very basics, from novice level to expert level. Yeah? So it is similar to the ROS2 Learning Week in this concept, but it's much more powerful. It takes much more time, etc. Yeah, but you are going to go from novice level to expert. And you're going to be prepared to work at any robotics company in the world. Okay? And you are going to learn with a combination of simulations, like we are doing during these classes, and practice with real robots. Yeah, so we have some remote real robot labs that you can connect to them from any place in the world. And you can practice with real robots, actually. Yeah? Remotely. And you are going to learn things such as C++. So for instance, this masterclass is much more focused on C++. Yeah, no Python. Yeah, because for companies, usually it's better to know C++. Okay, to start learning ROS2, it's better to do it with Python because it's much more easier. This is why we are doing it like this during the ROS2 Learning Week. But when you want to actually start working on a robotics company, then you have to learn C++, yeah? So for this masterclass, you are going to learn a lot of C++, you are going to learn how to use Docker for robotics, robot navigation, robotics theory, such as Kalman filters, robot control, mobile robot kinematics. You are going to learn continuous integration with Git, Jenkins, testing, and many, many other things, okay? And then at the end of the masterclass, when you finish this masterclass training, you are going to get a guaranteed 3-month internship at a robotics company. Okay, so that you can put into practice in a real company what you have learned during the masterclass. All right? And then this masterclass takes a period between 6 months to 1 year. Yeah? So you can take and do it the hardcore or the fast way. You can take the fast pace and finish it in 6 months, or you can go a little bit more slow if you don't want to dedicate so much hours a week to this masterclass. You can do it at a slower pace and finish it at your own pace in 1 year or more even. Okay? Yeah, and I am telling you this because the next masterclass batch, so the second batch, as you can see here, this second batch is going to start in September, okay? So if you are interested in starting a robotics career and get a robotics job, this is a very good option, so I really encourage you to have a look to this. I'm going to share the link right here very quickly in the chat. There we go. Okay, so you have all the information here. You can give it a look. You can download the full brochure, and you can enroll following this webpage. But yeah, I really encourage you to give it a look because it's really, really interesting, and it's a great option if you are a developer which want to start in the robotics world and want to get a career as a robotics developer. So this is a great fit and a great point to start and get you started directly and put you into a robotics company. All right? Okay, then, yeah. So let's get started. There we go. Is it a typical thing to work remotely in a job like this? Or I will have to move to South Korea on the side with the robots? That's a very good question, Arpad, but it's not easy to answer. I'm going to answer it very quickly, okay? But basically, it depends. It depends. If you focus... my very summarized answer to that would be, if you work with software, then it is very typical and it is perfectly doable to work remotely. Okay? If you are focused on software, on developing software for robots and working with simulations, it's very common to work remotely. Okay? In fact, many of our past students have been doing internships with robotics company remotely, okay? Because you are focused on working on the software, on developing software, yeah? On the other side, if you are going to work with hardware, then you have to be on site, yes or yes, yeah? Because you have to be there with the robot in order to work properly. Yeah, so it depends if you are going to focus more on the software side or the hardware side, okay? Or it can be even a combination of both. Yeah, maybe you can work remotely, but then from time to time you have to go to the site to work with the real robots and solve hardware-related problems, okay? Yeah, as Sergi says, if you use a physical robot or if you are in charge of something which is hardware related, then companies will expect you to be there. But maybe you are just developing software and you can work in a simulation and then it's not necessary to go there. It depends on many situations, okay? All right, then let's continue, okay? Let's continue. So I'm going to skip this example 1.3 and a very quick note, okay? So as you have seen from this simulation workspace, so packages are organized inside workspace. Yeah, every ROS2 package, as we were saying, is going to be placed inside a workspace. Yeah, and you can have multiple workspace. Yeah, so every workspace is going to have its own packages. Okay. Yeah, and then the structure is going to look something like this. Yeah, so you are going to have the workspace with the SRC folder, and inside the SRC folder, you are going to have all your packages. Okay? Oh, I can see here that Matev is asking DH tables. I don't know if you mean the Denavit Hartenberg tables, but this is taught in the masterclass. Okay? All right, so, yeah, then, very important that when you create a new package and you create programs, every time you are going to have to compile them, to build them, okay? In order to generate executables, okay? Then in order to generate executables, you need to build your package. And in order to build your package, you are going to build you are going to use this command, colcon build, okay? Then this command, the colcon build, is executed in the root of the workspace, all right? So, in order to create your packages, you have to be in the SRC folder, yeah? But once you have created your package and you want to build it, you have to go to the root of the workspace, yeah? And then in the root of the workspace, you are going to run colcon build, okay? This is also important. Okay, so keep this in mind, remember this. You have to build, you have to compile in the root of the workspace because it's a very typical error that that beginners in ROS start compiling inside the SRC folder, inside other folders, and then you can create there a mess. All right? So very important. Colcom build, the command used to compile a package, and you have to execute it in the root of the workspace. Yeah? So here I am compiling. Not much to compile right now, okay, because I have not created anything yet. So it's finished very fast. All right? And then every time that you finish building, you have to source the workspace. Okay? How do you source the workspace? With the source command. And then you have to source a file which is generated inside the install folder, okay? So an important concept to know is that, let me remove all this, build, you don't have to do this, okay? I'm going to do it, yeah? But whenever you compile in your workspace, these three folders are going to be generated. See, I'm going to compile now. I have removed these folders. I only have the SRC folder. So now I'm going to compile. And you are going to see that these three folders are going to be generated again. LS. See? Then you need to source this setup.bash file, which is generated inside the install folder. Why? Well, because this way you are going to let the ROS2 system know that you're going to allow the ROS2 system to get any changes, any updates that you have done to this workspace. Yeah? Otherwise, it might happen that the ROS2 system doesn't find the latest updates. Okay? Or is not able to find the packages in your workspace. Yeah? If you don't source your workspace, this is also a very typical common in beginners, that the ROS2 system, you try to execute a program in your package, but ROS2 says, hey, I cannot find this package. And it cannot find it because you have not sourced the workspace where the package is. This is a very common, okay? So very important, remember to always, after compiling, source the workspace, okay? Okay, and then whenever you run the colcom build command, you are going to compile all the packages inside the workspace, yeah? So all the packages which are inside the SRC folders are going to be compiled. In this case, we have only one. But if we had many packages, all the packages would be compiled, okay? Then it might happen that you just want to compile one package because you just have done modifications to one package, so you only want to compile that one package and not all the packages inside the workspace, yeah? Then for these cases, you can run the following command. Colcom build with the packages select argument, yeah? Here you have the full command, so colcom build, packages select, and the name of the packages that you want to compile, yeah? So by running this command, I'm going to only compile the my package, okay? Just so that you know. Let me have a quick look at the chat here. Is there a command to go fast to the workspace root, like cd ROS home? Not by default, okay? So you can create these kind of shortcuts, okay? There is one thing which is known as colcom cd, okay? But this is not provided by default in the ROS2 system, okay? So you have to do some things to your ROS2 setup in order to be able to use it. But if you are interested, you can give it a look. Okay, it's colcom cd. Let me write it here in the chat so that you can check it on your own. Okay, I can see that questions are being already answered. Is the setup bash created in the compile process? Yes. Why is there an error? Why is there an error? STDR. Okay. Yeah, don't worry about this. This is actually not an error. It's a warning. Okay. This is a known warning for ROS2 Humble distribution. Yeah, we are working in ROS2 Humble, and in ROS2 Humble there is this warning related to the setup tools, but don't worry because you can ignore it. Yeah, it's just a warning. It's not an actual error, and it is known, so you can ignore it. All right, let's keep going. Let's keep advancing. Then, what is a launch file? Okay, so we have already defined what is a package, what is a workspace, how you can compile packages. Then another of the concepts that we introduced was launch files, right? So what is a launch file? Well, basically, a launch file is a file that allows you to start ROS2 programs, okay? You can start one single program, or you can start multiple programs with one single launch file, okay? Which is it's one of the interesting things about launch files, because with the ROS2 run command, you can only start one program, one executable. With a launch file, you can start multiple executables, okay? Then basically a launch file is a file that allows you to start ROS2 programs, okay? Then, this is the general structure of a launch file, yeah? So, this would be the equivalent launch file in order to start the Tiliop keyboard program that we started at the beginning of the class, yeah? Then, basically what you do is to create a launch description object. Yeah, a launch description object. You return a launch description object which has to contain the following information: the package name and the name of the executable, yeah? There is another option, which is output. There are more options, yeah? But typically, you are going to also add this output option, and you are going to set it to screen. Basically, this says, okay, I want the output of my program to be printed to the screen, yeah? So whenever you execute the program, you get all the output, all these printed into the shell. Yeah, the screen means the shell, the terminal. Okay? Yeah, so this would be a minimal example of a launch file. Okay? So, three main things to specify: the package name, the executable name, and an output, a type of output to specify. Okay? Then, I have a quick look here at the chat. I can see many questions here. Okay. Okay. LTS, I can see Sergi is answering some questions already. Okay, so with a launch file, could you do two things at once with the robot, like continuous movement and laser measurement at the same time? Yes, but that's not because of launch files. So with a single program, with a ROS2 program, you can move the robot and measure laser readings at the same time. Okay? We are going to do that tomorrow. Okay? But with the same program, you can be moving the robot and analyzing laser data at the same time. With a single program, you can do it. Okay? So you don't need launch files for that. Okay? Is the knowledge transferable? I am currently learning iron. Can I apply the same thing to hammer? I will need... No. Yeah, exactly. It's almost the same, Samuel. So there are going to be some small changes between distributions, but the core knowledge is the same. But that is not the ROS concept. What do you mean, Marcus? Does the launch file start a thread for each ROS node? By default, yes. By default, yes. Okay? But inside the program, a single ROS2 program, you can specify it to execute multiple threads at a time. Okay, but these are much more advanced concepts. I don't want to get into that. Okay, all these, for instance, is explained in the ROS2 Basics course, which I left a link. All this is explained properly here. Yeah. So executors in ROS2 is a concept that allows you to manage the number of threads that your program is going to use. Okay. But this is a more advanced topic. We are in the basics one now, so I cannot spend all the time now explaining about threads because it's a much more advanced concept, okay? I don't understand your point, Marcus. One package for the CAM. Yeah, well, but yeah, so for instance, are we talking about hardware or are we talking about software? Okay, so for instance, for the drivers of the CAM, you are going to have one package dedicated to the CAM, to the drivers of the CAM. You are going to have another package dedicated to the drivers of the LiDAR. Okay, but then you can create a ROS2 program that uses information from the camera and from the LiDAR. Okay? So ROS and ROS2 work with topics. All the information is shared through topics. We are going to learn this tomorrow, okay, about topics. But ROS2, probably the main concept of ROS2 and also ROS1 are topics. All the information is shared on topics. Yeah? If you want to move the robot, you have to publish into a topic. If you want to get laser information, you have to get information from a topic. Yeah? Then the programs that you create can use information from different topics. You are not limited to only one topic. Okay? Yeah? Okay. Then let's do this exercise, okay? Let's follow this exercise 1.6, where we are going to create our first ROS2 program, okay? Then, for this, we are going to create a very, very basic ROS2 program. We are going to create this simple.py script, okay? Then, where do I have to place this Python script? Okay, I have to place it inside the my package folder, okay? Not the first one, but the second one, okay? The one that has this init.py inside it, okay? All the Python scripts that you create, you have to place them here, okay? So let me right-click. I'm going to right-click here, new file, and then create a new file named simple.py. Okay? And then inside this file, I'm going to copy and paste the code that you can find here in the notebook. Okay? Yeah? Then let's have a quick overview at this. So what are we doing here? First of all, we are importing RCLPy, okay? RCLPy is a must in Python, in ROS2 Python programs, okay? RCLPy is the library that allows you to create ROS2 code, ROS2 programs using Python, okay? Then, actually this line is not even needed, if I'm not wrong. I think that we can remove this line here. Yeah, we don't need it. Okay, then we create a function named main, okay? Then, from RCLPy, we call the init method, which is going to initialize a ROS2 node. Okay? Then we have a simple print. We already learned yesterday what prints are. And then we shut down the ROS communication. Okay? So this is, as you can see, this is a very stupid ROS2 program. We just initialize the ROS2 communication. Let's say we print something into the screen and then we shut down. Okay, so we are doing nothing here. Okay, very, very stupid ROS2 program. Later we are going to modify it to see some more interesting things. Okay? Then, next thing that we are going to do is to create a launch file in order to start this ROS2 program. Yeah? Then, launch files, always you are going to put them inside a launch folder to have them organized. Yeah? So in our package right now, we don't have this launch folder. So let's create it. Okay? Let's right click on the package, new folder, and create a new folder named launch. Okay? And then inside this launch folder, I'm going to create the new launch file. Okay? Here, as you can see in the notebook, there are instructions to do it through the shell, through the terminal. Okay, so you can do it as you prefer. Okay, then inside the launch folder, I'm going to create a new file named like this: my package launch file.launch.py. Oh, okay, yeah, this happens sometimes. As you can see, my launch file has not been created inside the launch folder. Yeah, so I'm going to have to manually move it there inside. There we go. So now you can see that it's inside the launch folder. Okay, and then here there is a quick exercise to fill the launch file. I'm going to do it using the solution directly from here. Yeah. Then here, as you can see, we need to, in the launch file, we need to import the launch description, and we need to import the node element, okay? Then we have to return a launch description with a node, yeah, containing the following information: the name of the package, which is my package, the name of the executable, which actually we don't know yet the name of the executable, or do we? Can somebody answer me this question? Do we know the name of the executable of our program at this point? Yes, no? Simple. Not until compile. Yes, no, no. Simple as it has the main. Simple py. No, 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 no. So, the correct answer so far is Joe Miller's. So until we compile, we cannot know the name of the executable. Okay? Yeah, Marcus also is right. He says we have to set up in the setup.py file. Exactly. Yeah. So for now, we are predicting that the name of the executable we are going to use is going to be simple, okay? But we don't know for sure yet, okay? Then the last step is that we need to update the setup.py file, okay? Then here we are going to do a couple of things, yeah? So let's open this setup.py file here, yeah? Then we are going to do a couple of things. The first one is that we are going to generate the executable, yeah? And this is done down here in the entry points inside the console scripts, yeah? This line that we have here, we need to add it to our setup.py, like this, inside the console scripts. Yeah? What does this line mean? This line means that we are going to generate an executable named like this. This is the name of the executable that it's going to be generated when we compile. Okay? So we can put simple here, or we can put something else. Yeah? For instance, here I'm going to put simple executable. Okay? Then this executable is going to be generated from the main function of the simple.py script. Yeah? So this simple.py script has a main function. Yeah? Then whenever I execute this executable, what I'm going to be executing is the main function from the simple.py script, yeah, which is contained inside the my package. Yeah? Do you understand this line? What's going on here? Do you understand? The name of the executable file and what this executable is going to execute. Sergi says yes. No, Joe Miller is asking, is output a screen because we are not outputting actions to a robot? No, output a screen just means that I want to print the output of my program to the terminal, to the shell. Okay? Any output that is generated by my program, I want to print it to the shell. That's what it means. You are right, Stefan. You are right. Stefan is saying, now I understand that. So you have to change it in the launch file too, right? You are correct. So if I don't change the executable name here, this is not going to work. Yeah. So I'm going to leave it like this now so that you see what happens. Okay. Then, okay. So here, what I'm going to do is to generate the executable. Okay. But I'm going to do something else in the setup.py, which is to add this line here. Okay? This line here, I'm going to add it down here inside the data files. Okay? What am I doing with this line? Basically, what I am doing with this line is to tell ROS2 that when I build this package, I want to install in the install folder all the launch files, so all the files that have this extension, which are inside the launch folder. Yeah? So inside the launch folders, any file that finishes with .launch.py, I want to install this inside the install folder. Okay? And why do I want to do this? Because otherwise, ROS2 is not going to be able to find my launch file. Yeah? Because ROS2 is going to look for executables, for launch files, inside the install folder of the workspace. Inside here, yeah? So, if I want my ROS2 system to find my launch file, I need to install it. Yeah, this is what I am doing in this line. Yeah? Then finally, here I'm using a couple of modules like OS, glob, that in order to use them, I need to import them. Yeah, so I need to add at the top these two files, these two import lines. Okay? All right, so now I am ready to compile. Then, where do I have to compile? Where do I compile? Here, inside SRC? Can somebody tell me? Where do I compile? ROS2 workspace. Okay, yeah, very well. Okay. So let's go to ROS2 workspace here, and then call cont build. Okay, so now I am compiling the whole workspace. Actually, I am compiling all the packages inside the ROS2 workspace, but it happens that I only have one package right now. Yeah? There we go. Okay. So now I should be ready to execute the launch file, right? Well, before, what do I need to do? I need to source, right? Yeah. After building, always important to source. And now I am ready to execute my launch file, which should start my program. But what happens? Oh, I'm getting an error. And the error says, caught exception in launch. Executable simple not found on the libexec directory. Yeah, so it's happening what we were predicting that would happen, right? So what do I need to do in order to fix this exercise? Can somebody tell me? What do I need to do? Executable, simple executable in launch file. Okay. Yeah. So let's update our launch file. Simple executable. There we go. Okay. So now I should recompile, right? I'm going to only compile one package now. My package. Okay. I am recompiling my package because I have done a modification. Yeah. So every time that you do a modification, you need to recompile. Yeah. Otherwise, if you don't recompile, the changes are not going to be taken into account. Okay. And also, I saw here Stefan saying you always source not dot. Yeah. I mean, it doesn't matter. You can also use the point. It doesn't matter. Yeah. This is just so I can also do it like this. It's exactly the same. Okay, so now I'm going to execute again my launch file. And now it worked, yeah? So it worked because I can see here that the print has been executed. Right? Okay, then very quickly, I'm going to skip this, okay? You can take a look at on your own later to get a little bit more in detail what these modifications that we did to the setup.py file, okay? Then let me introduce the concept of ROS2 nodes, okay? You can think of ROS2 node of a ROS2 program, yeah? Whenever you launch a ROS2 program, this program is going to be associated to a node, okay? So every time you launch a ROS2 program, this program is going to be associated to a node, yeah? So typically, in robotic systems, you are going to have multiple nodes which share information between them in different ways, okay? Then, in order to get a list of all the nodes that are currently running on the system, you use the ROS2 node list command, okay? So, ROS2 node list. Okay, so here you can see all the nodes that are currently running in the system, see? So we have a node for the camera driver. We have another node which is responsible of gazebo. We have here another node for the laser, you can see. Another node for the IMU sensor. Another node for the differential drive control system. Yeah? So we can see that we have different nodes. Yeah? Each node represents a ROS2 program which is in charge of something. For instance, this node is in charge of publishing the laser readings, the laser information. Yeah? The camera is in charge of publishing the images of the camera, etc. Okay? Then, our program, at this point, why is not appearing our program? Well, because our program actually is so simple that it doesn't even generate a node. Yeah? Because we are starting, we print something, and then we stop it. Yeah? So actually, if we want to generate a node which we can see and interact with, we need to leave our program running in some way. Yeah? So this is what we are going to do now. Yeah? We are going to update our simple.py with the following code that we have here. Okay? So let's copy this code and let's replace the one that we have with the new code. Okay? Yeah? Then let's have a quick look at this updated code. What have we done here? Well, as you can see, we are importing RCLPy. This is mandatory because we want to create a ROS2 program with Python. And also here we are importing the node class. Yeah? This is very important because every ROS2 program that you create is going to inherit from the node class. Yeah? This is the basic class. Whenever you want to create a ROS2 program, a ROS2 node, you are going to have to inherit from the node class. Yeah? So as you can see, we are creating a Python class here, which inherits from the node class. Yeah? Then here we have the constructor of the class. If you did the Python 3 course, if you finished it, you know what a constructor is already. Yeah? So here we have the constructor of the class. And inside here, in this line, we are initiating a ROS2 node with this name. Yeah? The name of the ROS2 node is going to be this, Byakugan. Okay? Then, also in the constructor, we are creating a timer. Yeah, we are using this function, create timer. Yeah? A timer is a function that is going to be executed periodically following a specific rate, which in this case it's 0.2 seconds. Yeah? So every 0.2 seconds, this timer callback function is going to be executed. Yeah? So whenever you create a timer, you have to specify two things: a period in seconds and a callback function to be executed. Yeah? Then this here I am implementing this timer callback. Yeah? Inside this callback function, this timer callback, what I am doing is to print a message. Yeah? In this case, I am not using print, which is the typical Python way of printing messages, but I am using the ROS2 way, which is by using the logger system, the ROS2 log system to print messages. Okay? Yeah? So this message is going to be executed every 0.2 seconds. Yeah, this moello, this very strange message, okay? Then, finally, I have my main function, where I initiate the ROS2 communication. I create an instance of the my node class, and then I spin this node. Yeah? Spin, it means that the node, the program is going to be active, running, until somebody manually stops this program. For instance, by pressing Ctrl+C in the shell. Yeah? And then, at the end, when somebody stops the program, we shut down the communication. Okay? Yeah? More or less, do you understand the structure of this code? Any questions related to this code? Can you output, Joe asks, can you output to a log file instead of the screen? Yes, you can. Yeah. That's possible, yeah. Is RCLPy spin referring to spin logs? Something similar. Yes, something similar. Joe. So the program is going to be spinning continuously, doing loops. Okay? And doing like iterations. Yeah, keep alive. Yeah, it's like keep alive, but making sure that all the callbacks are executed, and there is a bit more there. But don't worry, because we will learn more about this tomorrow also. Okay, it's going to be more obvious. Is a spin blocking, and so can we only spin one node per Pi program? That's correct, exactly. Yes, Sergi. You can only spin one node per Python program. Correct. Yes. You are right. All right, so I saw another message there. Well, with threads, it's different, because then we are going to enter with executors. Okay, so you are going to generate executors, and then with executors the thing changes. Okay, because you can have multiple nodes. You can add multiple nodes to a single executor. Okay, so with executors things change. Okay, but yeah, that's a bit more complex. But with a simple program like this one, or with simple cases, you can only so spins are blocking. Okay, so here we only have one single node. When using executors, you can have multiple nodes in one single program. Okay, but then the thing changes, because you don't have only one node, you have multiple nodes. Okay, and then you have the executor with which coordinates all the nodes, all the programs. Okay, then let's compile. So we need to recompile, because we have changed updated the code of our program, right? So let's recompile. Okay, source again, and run again the program. Okay, so now we start getting the message constantly, right? So what happens now? Well, if I stop with Control-C, my program finishes. Yeah, first of all. But what if I leave it running? Well, if I leave it running and I come to another shell, I can now run a ROS2 node list, and here we can see our node, Byakugan, which is here active. Yeah? And you can get information from any node using the command ROS2 node info and the name of the node. Yeah? Well, yeah, the name is wrong. It's Byakugan. There we go. Okay? So this gives us information about this specific node. Okay? And you can do it, of course, with any node. Yeah, to get information, specific information about one specific node. ROS2 node info, for instance, Turtlebot 3 laser scan. Yeah? And if we stop our program, of course, the node is going to go away. So we don't have it anymore here because the program has stopped, obviously. Okay? All right, so yeah, there are a couple of more explanations here, but I think we are going to leave it here. Let me do a last check to the... I think I missed something by accident. Yeah, probably you missed some step. Found in the shared directory of package. The launch file was not found. You mean, Logan? I see that Ruben is assisting you. Mine says that the file was not found. What file? The launch file, you mean? Or the executable file? Yes, the launch file. Yeah, then that is because you have not added this to your setup.py. Okay? So go back to the notebook, here where the launch file is, where the setup.py is, see? And copy this one, okay? You need to copy this one. Because probably, very likely, you don't have this line, and these lines neither. Okay? This line is the one that installs the launch file in the system, so that ROS2 can find it. Okay? Well, then if you have that line, then it's that you don't have the launch folder, or you don't have the launch file inside the launch folder. Maybe you have the launch file somewhere else, not inside the launch folder. Because here it's looking for launch py inside the launch folder. So maybe you have it somewhere else. Okay? All right, guys. Then if there are no more questions, more comments, I'm going to leave it here already. 40 minutes past the time that we should have spent, which is 1 hour. But yeah, I think that we covered many things. I think that it was a good introduction to ROS2. We introduced many important concepts. And yeah, I hope that you learned something, that you enjoyed the class. And tomorrow we are going to come back with probably the most important class, which is topics. Okay, very important class where we are going to see what are topics in ROS2, why they are so important, how we can interact with topics, and we are going to be actually controlling the robot with topics, getting information from the robot using topics, etc., etc. All right, so very important class tomorrow. I hope to see all of you there in the class. I suggest that you give a look to the notebook now. You get, as I said at the beginning, this project is already for you forever, okay? So you can keep working on it. You can open it tomorrow if you want to refresh all the concepts, okay? You can check all the explanations because there are some parts that I jumped, all right? And yeah, see you tomorrow with the topics class. And as always, take care and keep pushing your ROS learning. Bye-bye.